Usually I work with customers, but in this case I got to work with our own IT organization. Now they've taken our zero latency enterprise concept and implemented it within our own supply chain. They actually integrate more than 15 SAP instances using this technique. Now one thing I've learned about supply chain is it's complex, has a lot of software components that interact, but more than that, they have multiple instances of ERP systems running different parts of the company, each with its own picture of supply and demand. So it's very difficult to get a complete picture of all of my supply chain in one place. Now what we did was to enhance these best-of-breed ERP solutions by capturing critical data in real time to the data store that's located on this nonstop server in the room behind me. And all that information being captured, you can see here, we're running about 50 orders per second, around 100 supply events a second, around 400 requests for information, and several call center updates and requests, all being trickled into this database so that we have a complete picture of everything touching our supply chain. Now, one very powerful way to use that complete picture is a concept called available to promise, or ATP. And it's a really simple concept, is that we're really just trying to find out, when somebody asks, can we satisfy that order? Do we have enough supply to fill demand? And really simply, if an order comes in and we map that against supply, it should be a simple concept. But it turns out it's more complicated than this for 5 reasons. The first reason is that the orders don't come in just for today. They would say they'd like the order delivered by some date in the future. And we have to figure out the time it'll take to ship it to them and be able to determine if we can get it to them in time. So we have to have some type of an algorithm to look at supply that hasn't even arrived yet and understand if we can fill that or allocate it to demand. The second reason this is complicated is we might have a higher priority order come in that would bump or change the pegging of one of these allocated orders already, and that order then would have to go find new supply, and it could bump another order, and this cascading could go all through all of the allocations that I had figured out in advance. The third reason this is complicated is that we actually have to look at multiple locations. I might have a number of plants that could ship this item to you, and all of them have a different lead time to ship that item to the customer. In addition, when a high priority order comes in, this makes all this reallocation very complex. The fourth reason this is difficult is that what I've just shown you is really just one instance of supply chain. And we might have multiple instances running different parts of the company, the display division, the printer division, the access division. And so these orders come in, and they would span all of these different products, and they might, for instance, say they want all of them to be delivered on the same date. The final reason this is really hard is that we now have 2 of all these things. We just went through a merger. So we have HP systems and Compaq systems managing our supply chain. Now, while the merger made things more complicated for us, it also helped us find the problem. We took the ZLE engineers from Compaq, and we partnered with the HP Labs organization that does research and development, and we're able to use some very advanced optimization algorithms to create what we call an ATP engine. And it works like this. We have this hub that I described earlier sitting in the middle of all these different systems, and information is being fed to us. The ATP engine will allow an order to come in and ask if the item is available or not. And all of these systems then are propagating a real-time view of all their supply and demand to us, so that in one place, in real time, we can watch and reallocate all of the inventory and all the supply to make sure that we can meet demand. Now to see that work, I'll just come into a screen that allows me to request ATP. And if I pull up a certain order that I'm looking for, you'll see I'm asking for 3,000 of this certain unit, which is a UPS power supply. And you'll notice that it comes back and says it can't make the date. It's offering them on the 5th rather than the 3rd, which means we're not going to make the date they asked for. Now, the engine we built is smart enough to make a cross-sell, because we can always sell what we have in stock. And it actually recommends here that we use an HP comparable product. What this means is that our ATP engine and our ZLE hub are sitting between all the Compaq systems and all the HP systems, so that we get the benefit of an integrated supply chain before we actually integrate our supply chains. Now that I have this, I can notice that if you look at the screen that shows all of the available to promise over the next 30 days, the reason I couldn't satisfy the order is I don't have any inventory available in the first few days. It's all been allocated. So I could call my supplier and request more inventory, and that supplier might go into a vendor management system like this and say, on the 3rd day of the month, I'm going to give you 2,500 more units. When they do that, that event will be captured to our data store in real time, and if we watch the available supply, what we'll notice is that now supply will be added. And our ATP engine will actually reallocate all of the inventory and all of the supply across 13 plants to take into account that new shipment. And now we're going to have enough to actually meet our demand. If I go back to the ATP engine, I request that same request over again. Now it's going to say it can deliver it by the 3rd of the month when we ask for it. Now the other offer on the screen you'll notice is that for this ProLiant server, it's actually said it can't make that date either, and it's going to offer a new server which is a faster server. Now we could have offered a faster server or we could have offered a less expensive server. And the question is, how did we know which one to offer? The answer is we use data mining to extract data from our data store and feed it into SAS to do mining. Now the nonstop server is a great platform to do the hub, but the HP 9000 is a fantastic compute engine to do SAS with. So on the HP 9000, we actually will extract using this tool from Gina's data, and we'll feed it. You'll notice on the display here, we're now running all of the CPUs in our system at almost 100% as we extract a massive amount of data and feed it into the HP 9000 so that we can do these SAS analytics to figure out what the customer might be interested in. And the trick is, we have to do that in such a way that we don't impact all those other production workloads that are happening on the hub. And you'll notice that even with that huge extraction going, our response time and our throughput for all the different events and transactions that are being forwarded to us by SAP and forwarded to other systems are happening in exactly the same time. That's because the nonstop server is designed to do what we call mixed workload, to allow these workloads to occur concurrently and to be protected from each other. Now, what we've done in our IT organization is a great example of applying the ZLE concept to supply chain. But the concept fits about any industry, whether you're integrating data from supply or bank accounts or customer data or even terrorist data. It's really the same process. We integrate data in real time, we apply analytics to that in real time, and then we take action where needed.